Hey guys, Mr. Backward here. In this video, we're going to focus on writing equations of parallel lines. As we're taking a look at parallel lines, two lines are parallel to each other if they have the exact same slope. So in these first couple examples, what we're going to look at doing is saying what the slope of a line parallel to the following line would be. So in example number 1, we've got the equation y equals 3x plus 14. And the nice thing about this equation, especially when we're trying to identify the slope, is this equation is written in slope-intercept form, y equals mx plus b form. And as we're looking at an equation written in slope-intercept y equals mx plus b, we're going to focus on that m value because the m in the equation stands for the slope. So as we look at problem number 1 here, where we're given y equals 3x plus 14, if we look at the number in front of the x, this equation right now has a slope of 3. So as we're talking about parallel lines, well, earlier we said lines are parallel if they have the exact same slope. So every single equation that has a slope of 3 would be parallel to this original equation. Now, as we look at number 2, 2 is not written in y equals mx plus b form, so we don't want to just look at what's happening in front of the x. In order to do that, we would have to rearrange this equation to solve to get y alone. So with that positive 2x on the left-hand side, we could move that over to the right-hand side by subtracting 2x on both sides. So on the left-hand side, the positive 2x and the negative 2x cancel each other out, leaving us with just y equals. Now on the right-hand side, the 6 and the negative 2x are not like terms, so we can't combine those. But as we're writing this out, we typically like to put the x first. So I'm going to go negative 2x plus 6. Now this equation is written in slope-intercept form, so I'm going to look in front of the x, and right in front of the x is a negative 2. So this equation has a slope of negative 2. So every single line that is parallel to this equation will also have to have a slope of negative 2. Now in this last example, I give you two ordered pairs, and we're still talking about parallel lines, so we want to focus on the slope. When we're looking at 2 points, we can find the slope by using the slope formula, y2 minus y1 over x2 minus x1. So as I'm looking at my points, I'm going to label them. This first point, I'm going to call x1 and y1. And this second point, I'm going to call x2 and y2. So as we're looking at filling numbers into this slope formula, on top we're going to go y2 minus y1. So I'm going to go with 5 minus 8. And then on bottom, we're going to do x2 minus x1. So I'm going to do negative 7 minus negative 3. Now on top, if I take 5 minus 8, I'm going to get negative 3. And on bottom, if I take negative 7 minus negative 3, well, that double negative in there is going to turn into addition. So negative 7 plus 3 is negative 4. Now because these are both negative, when you take a negative and divide it by another negative, that gives you a positive answer. This fraction is not reducible at all, so we're just going to leave it as 3/4. So the slope between these 2 points is 3/4. So every single line that's parallel to this one also has to have a slope of 3/4. Now in this example, we're going to take this another step further. Instead of just looking at the slope of parallel lines, we're going to use what we know about parallel lines to help us write out an equation for a new line going through a specific point. So here in problem number 4, we want to write an equation for a line that contains the point 6, negative 4, and is parallel, these two vertical bars mean parallel, to the equation y equals negative 2x plus 5. Now remember, when we're talking about parallel lines, we said earlier that parallel lines always have the exact same slope. So if we want a line to be parallel to this original y equals negative 2x plus 5 line, we first want to identify what the slope of this line is. And we're going to do that by looking at the m value in front of the x, because this equation is written in y equals mx plus b form. So this equation that we're given, if we look directly in front of the x, has a negative 2 in front of it. So if we want a line to be parallel to this one, then as we write out our brand new equation, we're going to write out an equation with a slope of negative 2. Now, because we're told that we want our line to go through a specific point with this slope, we're going to use point-slope form to help us start writing this equation, but then rearrange it into y equals mx plus b slope-intercept form. So when we're writing out an equation in point-slope form, we have to remember that that looks like y minus y1 equals m times x minus x1. The m value is your slope, and the x1 and y1 values come from the point that you're given. So if we look at this 6, negative 4 point, I'm going to label that. The 6 is my x1 value, and the negative 4 is my y1 value. So I'm going to take these three pieces of information that I've got, and I'm going to plug them into this point-slope form. So we do y minus the y1 value, which we said earlier was negative 4, equals the slope. We're using negative 2 because we want it to be parallel to the original equation, so the same slope, times x minus the x1 value, which is 6. Now on the left-hand side, I do have a little bit of cleanup work that I can do. Y minus negative 4, that double negative in there turns into plus 4. So that's y plus 4 equals negative 2 times x minus 6. Now on the right-hand side, we're going to clean this up by doing our distributive property. So I'm going to take the negative 2 times the x to get negative 2x. I'm also going to take the negative 2 times the negative 6. Now, because these are both negative, when you multiply them together, you're going to get a positive answer, and 2 times 6 is 12. The left-hand side is still going to be y plus 4, so we haven't changed that at all. But I did say that we want to get our final answer in slope-intercept form, y equals mx plus b form. So I want to get rid of this plus 4 on the left-hand side. I want y to be alone. So to get rid of a plus 4, we're going to subtract 4 on both sides. So on the left-hand side, the plus 4 and the minus 4 cancel each other out, leaving us with just y equals. And then on the right-hand side, we've got this negative 2x. And if we take 12 minus 4, we're going to have plus 8. So because these two lines are supposed to be parallel to each other, that's what these two vertical bars mean, they should have the exact same slope, but they will end up having different b values, different y-intercepts. Now, as we look at problem number 5 here, we're going to write out an equation for a line that contains the point 9, 10 and is parallel to y equals negative 3x plus 4. Now, this equation is already written in slope-intercept form, so it should be fairly easy for us to identify the slope. It's the number in front of the x. That's our m value. Because we want parallel lines, we want to use the exact same slope, so we're going to use a slope of negative 3. We want to go through the point 9, 10, so we're going to use point-slope form again. So remember, that's y minus y1 equals m times x minus x1. We get the m from the slope. The x1 and the y1 come from the point that we're given, so the 9 is the x1 and the 10 is the y1. So I'm going to fill those in where they need to go. Y minus 10 equals negative 3 times x minus 9. There's no double negatives to clean up on this one, so I'm going to jump into the distributive property. Negative 3 times x is negative 3x. Negative 3 times negative 9, double negative turns into positive 27. On the left-hand side, we still have y minus 10. Just like we did on the last one, we want to get our final answer in y equals mx plus b form, so I want y to be alone. To get rid of the minus 10, I'm going to have to add 10 on both sides of my equation. So on the left-hand side, we get just y equals. The right-hand side, we're going to have the negative 3x. And if we take 27 and add 10 to that, we should have plus 37. So this equation is parallel to our original equation because they have the exact same slope, and because we used the point 9, 10 as we were doing our point-slope form. If we were to graph it out, we would see that it does go through the point 9, 10. Last example that we've got here, it's very similar to the last two in the sense that we want to write out an equation for a line that's parallel to a given line going through a specific point. But what's different about this one is as we look at the equation that we're given, this equation is not written in slope-intercept y equals mx plus b form. So we can't just look at the equation to find the slope yet. What we're going to have to do is take this equation and rearrange it to get y alone, and then we'll be able to more easily identify what the slope is. So we're looking at 3y plus 2x equals 9. We want y to be alone, so the very first thing I'm looking at is this plus 2x. To get rid of a plus 2x and move it over to the other side, we're going to have to subtract 2x from both sides of the equation. So on the left-hand side, the plus 2x and minus 2x cancel each other out. So we get 3y equals negative 2x plus 9. Now we still want the y to be alone, and we've got that 3 out in front. 3y means 3 times y. So to get rid of times 3, we're going to have to divide everything in this equation by that 3. So the times 3 and the divided by 3 cancel each other out on the left-hand side, leaving us with y equals. Now as we look at taking negative 2 and dividing it by 3, that's not reducible at all, so I'm going to leave it as negative 2 over 3, but the x is still attached to that. Now on the back end, 9 divided by 3 is nicely reducible. 9 divided by 3 is just 3. Now, we're talking about parallel lines, and we said earlier that parallel lines have the exact same slope. Well, now that this equation is written in y equals mx plus b form, we're going to be able to identify the slope more easily by looking at the number in front of the x. So we have a slope of negative 2/3. Now, we want to go through this specific 6, 5 point using this slope, so we're going to use point slope form. Y minus y1 equals m times x minus x1. I'm going to label my ordered pair. This is our x1, this is our y1. So I'm going to take those pieces of information and plug them into this point slope form. So we would get y minus the y1 value of 5 equals negative 2/3 times x minus 6. Now as we look at this equation, there's no double negatives to clean up, so I'm going to start by distributing the negative 2/3 on the right-hand side. So negative 2/3 times x is just negative 2/3 x. As we take negative 2/3 times negative 6, this might be a little trickier. I do notice that both of these are negative, and when you multiply two negatives together, you get a positive result. Now taking 2/3 times 6, I'm going to take that 6 and put it over 1 so that we can see the fractions happening. 2 times 6 on top is 12. 3 times 1 on bottom is 3. But 12 over 3 is reducible. 12 divided by 3 is just 4. So negative 2/3 times negative 6 is positive 4. Now we haven't changed anything on the left-hand side. That's still y minus 5. We do want to get y alone though. So as we're looking at that minus 5, I'm going to add 5 on both sides of my equation. So the plus 5 and the minus 5 cancel each other out, leaving us with just y equals. On the right-hand side, we have negative 2/3 x. And if we take 4 and add 5 to that, we should have plus 9 on the back end. So the parallel equation through that 6, 5 point is y equals negative 2/3 x plus 9. That's going to be it for this video. Thanks for watching.